Hey, what is going on, guys, and welcome back. We are continuing with first section in part 5, more lists. We finished doing the first exercise in this section called the longest string. That was basically the last thing that we did in the previous video. I just decided to end the video there because we had already done almost 40 minutes of straight reading content and working through some examples on the Python playground. So I figured we had taken a lot of time just to get to this first exercise. So in this video, we are hopefully going to be able to finish the remaining exercises as well as the remaining readings. Now, I will try to start putting chapters in the video because, again, as the videos get longer, maybe some viewers just want to get straight to the exercises and don't want to sit through the entire video hearing me yap and reading the material that's on the screen, where it might just be more helpful for some viewers to go straight to the exercises as we're working on the exercises and see what solution we get to, because they can do the readings on their own. So I think this might be the first video where I put chapters. If not, then the next video will be the one that I start putting chapters in. If you enjoyed your weekend, I hope you did. It was July 4th, so I took the weekend off, spent some time with my family, and I was a little bit sick, so it sucked, but we do the best that we can. So happy Monday. Let's get back into the swing of things. So this is where we left off. We're just going to continue straight where we're here in this chapter. This section in the first section of part 5. I feel like I said section like 10 times. All right, lists within lists. The items in a list can be lists themselves. Here we have a variable called myList, which is assigned this outer wrapping list, and inside of it we have these small lists. Some have 3 items in them. Another one has 2 items. This one has 4 items. And so this is nested lists, and I introduced this concept in the solution to the final exercise in part 4. They're also known as matrices or a matrix. They're a little bit harder to visualize when you're looking at them like this, but there's another exercise in this chapter that you will see that's going to make this even a little bit easier to visualize when you see it as like a board instead of a 2D box like this. So when we call the print function and we pass myList, it's going to print the full list, right? It's going to print the outer brackets and then all the sublists or the nested lists inside of our wrapper, just like this. And then we can also target individual indexes, right? The individual nested lists using list indexing like this. List index targeting like this with the square brackets. So if I were to do myList1, then it's going to print this, which is what's happening here. And if I were to do myList followed by, so we say, hey, go to myList, target the first item, and target the item at index 1, and in that item, target the item at index 0. So that will be the 4, right? We're saying scan the list, go to the item in index 1, which is this nested list, and then inside of that nested list, get the first item, which is the 4, and that's what's being printed here. Why would lists within lists be useful? Remember, the list can contain items of different types. You can store information about a person in a list. For instance, you could include their name as the first item, their age as the second item, and their height in meters as the third item. So here we have a list with the first item being this name Anne, the second item being this integer 12, which signifies their age, and the third item being this floating point number 1.45, which signifies their height in meters, so 1.45 meters. A database of a person could be a list whose items would be lists containing information about a single person. Here we have a variable called persons. It's assigned this big list of nested lists, and each item in this list signifies an individual person. So we can loop through our list and get certain details about them. So we can say for person in persons, name, right, is equal to person 0, meaning the nested list, the first index in the nested list, so that'll be their name. Then the age will be the second item, right, index 1, and the height will be the third item, which will be index 2. And then we can print that information here. So we can loop through this and print those details. So we can print their name, their age, their height over and over and over again. Now this is useful in an instance where you have data like this, in which all the items in the nested list are ordered exactly the same, right? We know that the second item is always going to be that person's age. We know the first item is going to be their name, and the third item is going to be their height. The for loop goes through the items in the outer lists one by one, right? We know how for loops work. That is, each list containing information about a single person is in turn assigned to the variable person. Lists aren't always the best way to present data, such as information about a person. We will soon come across Python dictionaries, which are often better suited to such situations. Matrices, a two-dimensional array or a matrix, is also a natural application of a list within a list. For example, the following matrix, right? Now this is what I was talking about. This might be a little bit easier to see this, right? So this is, imagine if this data, right, our list within lists, pardon me, our list with nested lists was to be displayed like this. So the first item will be printed horizontally like this. The second list will be printed horizontally like this. And then our last list will be printed horizontally like this. Now you can see that it's this board, it's this matrix, right? We have rows, we have columns, and we have rows. And it's easier to say, hey, my matrix at 0, 0 will be this item 1. My matrix at 0, 2 would be this. My matrix at 0, not 0, 2, 0, 1 will be this. At 0, 2 will be this, etc. So this is an easier way to visualize what this is doing. Since a matrix is a list containing lists, the individual elements within the matrix can be accessed using consecutive square brackets. The first index refers to the row and the second to the column. Indexing starts from 0, so for example, my matrix 0, 1 refers to the second item on the first row, right? This. So when we do this, it prints, pardon me. Well, when we do this, it's going to print this, and then we can target a certain index and change it. So we can say, hey, at row 1, index 0, so the 3, change that to a 10. So then when we print my matrix, you can see that 3, which was over here, became a 10, right? And then again, when we target this, it's going to return that 2, which is this. Like any other list, the rows of the matrix can be traversed with a for loop. The following code prints out each row of the matrix on a separate line. For a row in my matrix, print row. So it's going to print each list from left to right in like this. Likewise, nested loops can be used to access the individual elements. The following code prints out each element in the matrix on a separate line with the help of two for loops. Right, so for a row in my matrix, print a new row, and then for element in row, print element. So now, print a new row, then it's going to print each element after. So 1, 2, 3, it will be this, 1, 2, 3. Then a new row, print 4, 5, 6, which will be the items in this nested list right here. And then so on and so forth. So we can use nested for loops to target individual items within nested lists. So this is, again, pretty straightforward, I think. If you're having issues being able to understand this a little bit more, let me know, and we can play around on the Python playground in a separate video, just so you can get to see this in action. But again, I think, in fact, if we were to say, for example, let's do this. Let me copy this, go to the Python playground here. Let me paste it, right? If you were to look at this, a little bit harder to read. So I would recommend when you're writing nested lists like this or matrices, do it like this, right? Just indent, right? Just go each row, press enter, press enter, and then do that, right? So this might be just a little bit easier for you to read visually than looking at it in this 2D format like this. Maybe looking at it in a 3D format might be easier to see. So now you can be like, hey, I want to target the first row, first item. I know it's going to be 0, 0. So when I do print, my matrix 0, 0, right, should print 1. My keyboard is a little off center, so when I print 1, it should print 1 here. And it does, right? So this might be a little bit easier for you to read. If I were to say print print this item, we know, hey, this is the final row, right? This is row 3, which will be index 2, and then the final item will also be index 2. So we can do print 2, 2 like that. It should print 9, and it does. Okay, so this might be just a little tip. Writing it this way might be a little bit easier for you to visualize and work with until you get more comfortable, and then in the future you can just continue writing them as 2D lists like this. Okay, visualizing code containing lists within lists, programs containing lists within lists can feel hard to grasp at first, which is what I was just talking about. The visualization tool from Python Tutor is a great help in understanding how they work. The following is a visualization of the example above. Again, we've used this tool in the past. I don't rely on it too much, but it is helpful when you're having trouble. So I'll leave the link in the description for anybody who wants to go check it out, who isn't following along directly on their own, reading the material on the course and just watching the videos. But yeah, it's like a step tool. It will go through each line of your code or whatever code that you give it. It'll go in line by line and execute that code and point to what the code is doing in that moment. So the image above reveals that a 3x3 matrix technically consists of 4 lists. The first list represents the entire matrix, right? So in this instance, technically, these are 4 items because the wrapper itself is also an item, right? So when you print the entire list itself, that will be the first list, and then this will be the second list, the third list, and then the fourth list. So this is what it means. The 3 remaining lists are items in the first list and represent the rows. As multi-dimensional lists can be traversed with nested loops, it will be natural to think of the lists themselves as nested. But the image above shows us this isn't actually so. Instead, the list representing the whole matrix points to each individual list representing a row in the matrix. This is called a reference, and in the following section, the idea will be explored more thoroughly. Right, and I brought this up in the past, which is one of those things where I feel like they should have talked about a little bit. This is, I'm pretty sure, in a college setting, in an actual classroom, this will be taught in your introductory to programming course like this one. But if you're actually doing it in a classroom setting with a professor, they talk about when you're working with data in programming, right? When you pass data to a function, whether you pass it through reference, which means you pass the variable name that points to the data, or you pass by value, which means when you actually pass the actual data type, right? If you pass, I'll demonstrate by this, right? So look at this, for example, right? We have a variable here called myMatrix, and it's a list with nested lists, right? Now, when I call the print function and I pass the variable, the name to the list, right? My matrix, I'm passing this list by reference, right? I'm telling Python, hey, in order to find where this list is stored in memory, reference it by using its variable name or the variable name that we assigned to point to it, right? However, if I was to say, do this, and then do 0, 0, then this is called passing by value, right? We're passing an actual data type to the print function, right? So this still points to 1. This still works, right? We're passing the actual data type, the actual list with nested list in it, to the print function, right? It's the same thing as doing this, right? Print the number 2, or print 1.456, right? We're passing an actual value to the print function or to some other function that we create manually or whatever the case may be. So when you try to work with data and you pass a variable name, that's called passing by reference. But when you pass an actual value, that's called pass by value. So again, this is one of those topics that you will learn in a classroom setting. If anybody hasn't gone to college for computer programming or computer science or whatever, or software engineering, that's one of those topics that you will cover, a little bit more in depth. But it's covered. It's brought up pretty early. So the fact that we got to section 5 without it really being talking about that much, it's kind of crazy. But it's neither here nor there. But yeah, it's one of the things that you should know. In the image above, the execution has progressed to the second row of the matrix, and this list is what the variable row currently refers to. So again, right, row is now referencing each list, right? So every single time we cycle through my matrix, the first time row will point to the first list, nested list. Then when it finishes doing whatever it's doing, it's going to point to the second list. Then it's going to finish what it's doing. It's going to point to the third list, and so on and so forth. So, when my matrix, you can see it here in the global frames, my matrix is the actual list, and then row will be each sublist. And then the element will be the index of each sublist. So that's what this image is trying to show us. Again, you could have a better time seeing this if you go to the visualization tool. But I'm not going to do that because it's going to take up a lot more time than we need to focus on this. But yeah. But you know what? Let's just do it. Where's the code for this? Here we go. Let's just copy it. Let's just go do it. Right. So first, Python is pointing straight to the first line where we declare this variable myMatrix and assign this matrix. Then we start our for loop. So for row in my matrix, right? So now that line gets executed. Then Python is going to immediately set up the next line it's going to execute, which will be printing a new row. So now here it prints. Then for element in row, print the element. So now, right, it's going to the next line here. So this green line is always staggered, right? It's telling us, hey, the next thing that's going to be executed is this line. Then the green row will come down. The green arrow will come down. There we go. Now it's going to print 1. It's going to do this, right? Then it's going to just stay in here, print each item before it resets what row is pointing to. So now row first is pointing to this. Element just printed this, and now it's going to be pointing to 2, so it's going to print 2. There we go. Now it's going back up because element now moves down one more index. Now element is pointing to 3, so when we print element, it's going to print 3 here. There we go. Okay, now we finished going through this sublist, this nested list, the first one. Now row is going to point to this next list. Then when we print a new row, that's when now Python is now working with this. Okay, now we're going to start printing through all the elements. Now element points to 4. So when we call print element, it's going to print 4. There we go. So that's basically what this is explaining, right? Each time where row is looking, where the matrix is looking, where element is looking, right? You'll see this change every now and again. Now we go. So now row is pointing to the last item in the list, and then boom, when you get to the last item, and there we go. Right, so that's what this visualization tool does. It works with other languages too. So if you're learning JavaScript, C++, C, or Java, you can also use it for that. But yeah, it's a neat tool. VS Code also has similar functionality built into it. We covered it in the previous video. But yeah. Okay, accessing items in a matrix. Accessing a single row within a matrix is simple. Just choose the desired row. The following function calculates the sum of the elements on a chosen row. Here we define a function called sum of row. We give it a matrix and a row number, which is an integer. Then we have a variable here called row, which points to my matrix at the row number. We declare a helper variable called row sum, which is going to keep track of our sum of the items in each row. Then we're just going to loop through that row and add each item in that row to the sum, then return the row sum. So here, when we call my sum, and when we declare this variable my sum, we assign it the calling of the function sum of row. We pass it this matrix M that we defined here, and then 1. 1 is going to refer to the row number, so it'll be this row. So when we call sum of row, it's going to take the matrix and the row number, so we know it's going to work with this row only. Then when we print the sum, it's going to be the sum of, I'm sorry, not 1 is the index, this one, not this one. This will be 0. So now it's going to do 9 plus 1 plus 12 plus 11, which is 33. So when we call print my sum, it's going to print 33. Now, working with columns is slightly more complicated as the matrix is stored by rows. So here we define a function called sum of column, my matrix, and then the column number. Go through each row and select the item at the chosen position. Here we have our helper variable column sum, which is going to track the sum of the items in our defined column. Then for row in my matrix, column sum plus row at column number. And then so that way we can get the column number. Because we access first by rows, we need to, for each row, go to that to the specific index that's going to point to our column. So for example, if we wanted to get the values at index 2, at column 2, which would be 0, 1, 2, which would be here, so it would be the 3, the 12, the 9, and the 15. We give it the matrix, and then we give it the index number, or the column number. And so it's going to go in each row, target that index, right, that column, and then add it to the column sum, and do that for each row until we get the sum of 39. The column handle here consists of the elements at index 2 on each row. The visualization tool is definitely recommended for understanding how these functions work. Again, you can do this if you would like. I don't think it's that complicated. I'm used to it, so I don't think it's that complicated. But anybody who does need a hand, here we go. We just run through this real quick. So, right, we defined the function, we defined our matrix. So now we assign a new variable that calls the sum of column function, past the matrix, past the column that we want. And then now we go inside our function, plug in M as the matrix and 2 as the column number. As you can see it here. Now our column sum is 0. Now go through the row and add up the items at that column number that we want. So it's going to do this a couple of times till we go through the entire list, and then it returns 39. So that's it. Again, it's not that complicated, but it does help to use the visualization tool. The column handle here consists of elements at index 2 in each row. The visualization tool is definitely recommended for understanding how these functions work. Changing the value of a single element within the matrix is simple. Choose a row within the matrix and then the column within the row. Okay. Again, this is I'm not trying to rush through this per se, but yeah. If you're new to this topic, I will recommend that you just take a little bit longer to go through this. I feel like what the course should have done is given us exercises that tell us to work with matrices. So maybe this should have been one of our exercises. Hey, define a function that adds up the column value, the sum of columns. Define a function that sums up the rows, right? I think that could have been 2 really good exercises instead of repetitively making us read almost the exact same code over and over and over again. but it does help to just read through it and try to digest what the code is doing. Um, Here, this function is called change value, and we give it the matrix, we give it a row number, we give it the column number, and the new value. So here, our row will be the matrix at the row number that we provide, and then the column number that we provide, we call row, and set the new value at that column number. So if we wanted to change, for example, the item at row 2, column 3, so that would be 0, 1, 2, and item 3 will be 0, 1, 2, 3. So this 5 is going to change to 1000. So when we print M, right, this 5 here, right, or here I should say, because we're printing the original one and then we're printing the updated one. So this 5 turned into 1000. Notice how above we use the indexes of the row and column to access a chosen element. If we want to change the contents of the matrix, we have to access the elements by their indexes. This means that we can't use a simple for item and list loop to traverse the matrix if we want to change the contents of the matrix. Yes, because that will basically change, I think, every element at that column number. Instead, we will have to keep track of the indexes of the elements, for example, with a while loop for a loop using the range function. The following code increases the value each element in the matrix by 1. For I in range, using the column of rows. For j in range, using the number of items on each row. All right, m at I and j plus 1. So now each item in our nested list goes up by 1. The outer loop goes through the indexes from 0 to the length of the matrix, that is the number of the rows in the matrix. The inner loop goes through indexes from 0 to the length of each row within the matrix. Okay, we have our first exercise after 27 minutes of pure yap. Please write a function. It's called number of matching elements. I already have VS Code loaded up. We'll switch in a second. It says, please write a function named count matching elements. Takes in a matrix, which is of type list, and an element, which is an integer, which takes a two-dimensional array of integer and a single integer value as its arguments. The function then counts how many elements within the matrix match the argument value, an example of how the function should work. We define this matrix, a bunch of numbers. We call the print function, pass the count matching element function that we defined. We give it the matrix and the element that we're looking for. So we're looking for element number 1. So 1 shows up how many times? 1, 2, 3. So our function returns 3. Okay. Let's switch to VS Code. Here we are. Already have the file opened up. No need to waste time on that. We need to define a function called count matching elements. So I'm just going to copy the name of it here. Right, define, do that. Then we need to just do for row in my matrix, for item in row, if item is equal to element. In fact, we need a helper function variable here called counter, set that equal to 0, counter plus equals 1. Then we return counter. And then for testing purposes, we will open this and just copy and paste everything. Let's run this. There we go. It prints out 3. Let's test. Okay, it failed. So it wants us to put this inside the main block, even though it didn't tell us, but whatever. If name is equal to main, then do that. So let's run this again. There we go. Our test passed. Send solution to the server. There we go. We're going to open the model solution as well, so we can take a look at that real quick. And there we go. To find the same thing, they have a helper variable here called n for row in my matrix, for cell in row. If cell is equal to elements, n plus equals 1, return n. Exactly what we wrote but we just use item in row instead of cell in row, and then we use counter instead of n, but we still return counter. Okay, go back to here, refresh, make sure we get credit for that, and we did. Now, again, this is what I was talking about earlier, way earlier in the video, right? Nested lists might be a little bit easier to read when you look at them like this. Yeah. A two-dimensional array as a data structure in a game, a matrix can be very useful data structure in many different games. For example, the grid of a Sudoku game in the image below, right? This is a matrix, right? So if you're trying to look at the world and try to see if you can find, inspiration or how something could be visualized in a programming sense, building games, right? We use matrices a lot when you're building games. So, this is one of those ways you can look at it. Hey, if I was to build myself a Sudoku game, then we're going to need a matrix like this. So we can represent this as a matrix, right? So 9 is up here, followed by the 8, which is there, followed by the 3, right? So 0 represents an empty cell in the Sudoku game. And then each other cell that has a value other than 0, right, a positive number other than 0, is an actual value. Here the value 0 represents an empty square, right? And as 0 is not an acceptable value in a finished Sudoku puzzle. Here is a simple function for printing out the above Sudoku grid. Define print grid Sudoku for row in Sudoku for square in row. If square is greater than 0, print square and then 0. Otherwise, print an empty string with an underscore and then print grid Sudoku. So it's going to print like this. Right? It's not perfectly square, right? We're missing the borders. We're missing the dividers of each grid, of each sub matrix. It's pretty good. Any common game with a game board layer can be modeled in a similar fashion. Among others, chess, Minesweeper, Battleship, or Mastermind are all based on a two-dimensional grid. For Sudoku, it is natural to use numbers to represent the game state, but for other games, different methods may be better. Here we have another exercise called Go. In a game of Go, two players make turns to place black and white stones on a game board. The winner is the player who manages to encircle a bigger area on the board with their own game pieces. Please write a function named who1, which takes a two-dimensional array as its argument. The array consists of integer values, which represent the following situations. 0 is an empty square, 1, player 1 game piece, 2, player 2 game piece. The scoring rules of Go can be quite complex, but in this exercise, it is enough to compare the number of pieces each player has on the game board. Also, the size of the game board is not limited. The function should return the value 1 if player 1 won, and the value 2 if player 2 won. If both players have the same number of pieces on the board, the function should return the value 0. Okay, we don't have any test cases in here or a matrix to define, so I don't think we have to do anything beyond just writing the code. But it'll tell us if we're doing something wrong. Okay, player 1 is equal to 0, player 2 is equal to 0. Whoops, forgot the define keyword. For row in game board, for item in row, if item is equal to 1, player 1 plus equals 1, else item is equal to 2, player 2 plus equals 1, if player 1 is greater than player 2, return player 1, return 1, else if player 2 is greater than player 1, return 2, else return 0. sorry, return 0. Okay. See if we get any errors. Okay, that passed. Right, because they didn't give us any test cases, so we don't really have much to test this with. I mean, we can make our own matrix and populate it with some ones and zeros, but it's not really necessary. Let's send that solution to the server and open the model solution on the browser. Right, do the same thing, points for 1, points for 2. If square is equal to 1, increment 1, else if increment 2, then compare the two, or return 0. So it's the same thing we wrote, just use different variable names. Let's go back here, refresh, and there we go. Here we have another exercise called Sudoku check row. Please write a function named row correct. It takes in a list called Sudoku and a row number, which is an integer, which takes a two-dimensional array representing a Sudoku grid, and an integer referring to a single row as its arguments. Rows are indexed from 0. The function returns true or false depending on whether the row is filled in correctly. That is, whether it contains each of the numbers 1 to 9 at most once. Okay, that's very complicated. Okay, I took a second to think about this, and I think I have an idea of what it wants us to do. So let's just give it a go. So here we define a function, and we're going to define a list called track items. So that equal to an empty list, and we're going to say for item in Sudoku row number, if item is in track items, then return false, else if item is equal to 0, continue. Then we're going to do track items that append item, and then we can return true. That way we can do this in test. Right? Because so what's happening here? We create this track items list, an empty list, and we're going to use it to keep track, because the objective is to see that the numbers 1 through 9 appear once. Not at least once, appear only once, right? So if we have a row that has two values that are the same, like if there were 2 9s here, or 2 8s, or 2 3s, then that will be a fail, because in a Sudoku, each row and each column needs to have the numbers 1 through 9 appear only once, right? That's how you win. So what's going to happen here is we create this empty list. And then for each item in our Sudoku's row, right, if that item is in our list, then automatically return false, because that means we're already wrong. But if the item is 0, it just means that we haven't inputted it's just an empty space. So we do continue to skip it, right? Bypass this. Don't add this to the list, because if we were to append it, then the next time it sees 0, it's going to return false, and it's going to give us the wrong answer. So we do continue here to bypass appending 0. So if either one of these conditions, so if this doesn't evaluate and this continues, then we can append that item to our track items list. And then once we've done all of that, then return true, right? Because we need an immediate kick out if we do have repeating items in our track items. So this immediate return is going to kick us out of the the loop and our function, which will tell us that there's a duplicate number in here. So for example, if we do Sudoku at row 0, right? So we're working with this row here. So let's move this up here, a comment like that, so it's easier to read. Right? So let's say we're working with this row. So it's going to say for the item in this row, from our Sudoku, so this row, right? If item is in track items, right? Track items is currently empty, so this doesn't return false. Then we check if the item is equal to 0. The first item is 9, is the number 9, so so this doesn't do anything either. So we add 9 to our empty list. So now our track items will have the value 9 in it. Okay, then it's going to go again for the item 0. 0 is not in the list yet, so it doesn't return false. And because it's a 0, we're going to bypass it, right? So nothing's going to happen, and we're not going to append it to our items list. So it's going to do this for the next 3 0. Then it's going to visit this 8. 8 is not in the list yet, so it's not going to return false. And 8 is not equal to 0, so it's going to append 8 to the list. Now the list has 8 in it. Same thing. Again with a 0, then with a 3, it's going to add the 3, and then 0, 0. Actually, give me 1 second. So yeah, actually, I think it would have been even easier to plug in our solution here so far. But as you can see, it's added the 9, right? It's gone through the 0, and right here, and it's not adding the 0 to the list, our track list. So that's just what I wanted to check. So again, it's going to get to the 3, right? 3 is not in our list, so it's not going to return false, and it's not 0, so we append it. Then it's going to check the other 3 zeros, right? They're empty spaces, so it doesn't matter. And then it's going to return true. But if we were to do it with this row, okay, so let's see what's going to happen here. So for each item in this row, right? Sudoku a row number, this will be this row. So for item, so the first item is 2. Is 2 in our track list? No, it's not, so it doesn't return false. Is 2 equal to 0? It's not, so it's going to append 2 to our list. Then it's going to do the zeros again. Again, we bypass that, right? Because 0 is not in our list, and we don't want to track the zeros because it's going to give us an error. So not give us an error, but it's going to give us a false the next time we encounter another 0. So we don't want that, so we bypass it. Okay, it's going to do the next 0 again. It's going to bypass. Then it's going to come to this 2. Is 2 already in our track list? It is, so it's going to return false because we've hit our error condition, right? Remember, in a Sudoku, to complete the Sudoku, each number needs to show up once. Each number between 1 and 9 needs to show up once in each row, and in each column and in each row. So because 2 shows up twice in the same row, that means this row is invalid. So we return false. So I think this should be the passing solution. So let's put this through our tests, and it worked. Send that solution to the server. Okay, let's see the model solution. Okay, they did it a lot cleaner, right? For number in Sudoku row number, if number is greater than 0 and number is in numbers, return false. Right, this is even cleaner. Otherwise, append that number to the numbers list, and then we return true. So this is shorthand of what we did, right? Just a little bit shorter than what we did. Right, if number is greater than 0 and number is in numbers. So it's, if we're to say for item in track items and item is greater than 0, then return false. Otherwise, do the append. But yeah, both solutions are exactly the same. This is just a little bit shorter. All right, awesome. We're making good progress. Let's refresh this. That's passed. This is basically the same thing, but we just have to check the column. And it's using the same values. So we'll just go ahead and copy all of this. Open this one. Paste everything in there and change this to column correct instead of row correct. And we're looking for the column number. And that's it. So we need to just change this. So for row in Sudoku, for item in row, right, so we just do, we need to change this to column number. Oh, where do we go? There you go, column correct, like that. And we're gonna do for row in Sudoku, then if row column number in track items and row column number greater than 0, return false. Otherwise, track items that append, like that. So I'm borrowing the solution from the model solution that we saw here a little bit. And then we just do column correct instead of row correct. And we do 0 and 1 again. So let's see what happens. And there we go, that passed. So let's just, 1 second, just walk through the solution here. Okay, so we define a function called column correct, which takes in a list. This list called Sudoku and the column number. We declare our tracker list as we did in the previous solution. Then for the row in our Sudoku, look for the item, right, the column number in that row, and see if that item is in our tracker list and that value, right, the value of that column is greater than 0. If both of those are true, then return false. Otherwise, append that value to our tracker list and then return true. So if we were to do this successfully, right, append all those items over and over and over again, then we know that is that column is correct, so we return true. So if we were to work with this column, for example, here, right, this will return false, and this will return true. How do we know that? So let's work with the first column. So it's going to go, so it's going to do that row first, right? Then it's going to look at column, the item at index 0, right? Because we passed in 0 here. So row index 0, see if, which will be the number 9, see if it's in this list. It's not, and it's also greater than 0, so return false. Okay, I'm sorry, it's not going to return false because 9 is currently not in this list. So it's going to append 9 here. Then it's going to go to the next row, item 0, right? 2 is also not in this list. So it's going to append 2, right? This is a 0, so we're not going to worry about it because it's not in the list anyways. And then we're going to see this 2 again. 2 is in the list, so that's why it's going to return false. If we're to do this list, it's going to do the 0. So let's do that second list. So 0, it's going to skip. 0 is going to skip. It's going to see the 2. It's the first thing it sees. It's on the list. It's going to append it. It's going to see the 9. It's also going to append it. And it's followed by a bunch of zeros. No other repeating 9s or 2s, so it's going to return true. So that's why this solution works. It's pretty simple. Okay, let's just save it. Test this code again. Send that solution to the server. Show model solution in the browser. Close these other tabs that we don't lose. And there we go. But they did it this way, right? Number, they first assigned that number, then did the checks to return false or to append. We just did it in line here, like this. But again, same exact solutions. If we go back over here, refresh, and we get the credit for that one. And this is Sec 2 remaining exercises. It's called check block. Okay, this is lengthy. Oh my God. I'm feeling a little bit lazy, guys. Ew, what's going on with me? What's going on with me? I'm trying to work back into the swing of this, and wow, I was genuinely sick this past weekend, so I just need to take it easy. So I think I'm going to leave these last two exercises for the next video. There won't be as big of a gap between this video and the next one. It's going to cover these last two solutions. And I was sick with cyclosporiasis. I think that's how it's pronounced. It's a stomach parasite. It absolutely did a number on me. So I'm still recovering from that. I feel a lot better today, but not at 100% yet. So yeah, I just need to pace myself before I jump in full head and sit in front of my computer for another hour and a half trying to finish this video. So I'll do these last two exercises. I know I promised to do them everything in this video, but again, we're almost at the end. The next video will probably be like 15 minutes at most to cover these last two solutions. So I'll see you guys in the next video. If you have any questions about what we covered in this video, please ask it in the comments below. I'll try to put chapters. So when we're covering, so anybody who just wants to go sort of the solutions, they can skim through and get to those chapters. I'll edit the video again after it's uploaded to include chapters. Because right now I don't have the energy. I just burned through my entire energy in the last 51 minutes. So in the next video will be these two remaining exercises, and we'll be done with section 1. And then in the next video, we'll move on to the video after that one. We'll move on to section 2, which is about references. Okay, again, if you have any questions, let me know in the comments below. The solutions will also be uploaded to GitHub. So if you just want to go ahead and read the solutions, you can do that as well. Again, if you have any questions, let me know in the comments below. I will include a link to the Python Playground because we use it so much. If you don't have access to it, I'll put it in the description, as well as the Python Tutor Visualizer tool. That will be in the description as well. So if you enjoyed this video, please give it a thumbs up, and I'll see you guys in the next one. Also, make sure you subscribe. Again, your support means so much to me. The encouragement has been awesome. I'm trying my best. I'm trying to push through it, whether I'm busy or sick or, got something going on. I'll always try to make at least one video a week, but I'm trying to work back to making multiple videos a week. So again, your support, guys, has been so incredible to witness. I didn't think many people would be watching these videos, but when I check my YouTube studio thing, and I'm just seeing, so many people watching it. I've seen the likes and the comments encouraging me to keep making more videos, which I'll continue to do. So thank you so much, guys. Your support, again, means the world to me. I'll see you guys in the next video where we'll finish section 1 and move on to section 2. Yeah. All the links in the description. Chapters will also be done. So thank you.